All right, I think I'm live now. I had a weird thing happen where I thought something was wrong with my monitor, so I was switching the cables, and I moved the one that goes to my docking station, and it's also charging my laptop. I switched it, and I forgot, and that was like 2 or 3 hours ago. So battery died and I wasn't really sure what was wrong. So yeah, and it took like 5, 7 minutes to charge it enough, so I'm able to turn the laptop on. But anyway, I'm here. Just want to make sure that it's streaming because all of my everything got restarted and reset. So I'll have to open a lot of my old windows. But I guess I am live, so that's fine. And I also find the links that I had open, and I'll start sharing the screen. Uh, let's see. Hopefully I can get the demo to work as well, but we'll see. What I want to do first is I just want to go through the document. So let me share my screen here. Present. Just gonna do window. Yeah, let's do window, and then I'll switch when needed. All right. Which one? Let's do this one. I guess this one's fine. I'll zoom in a little bit. I'll post the link in. So anyway, what I want to talk about today is yesterday I noticed there's a PR out for changing the way that redirection is done in ambient mesh, which will make it work with any CNI as well, right? So I figure it's going to be an interesting thing to go through the document and see how it works. Read how it works, try to understand it. I might go through the code a little bit as well, but that's an issue. There's a bug here. I'll post this document here, and this is publicly available, so anyone can go through this as well. So this is that proposal. Just post it on LinkedIn as well. And this basically explains how this works, or how will it work. Just mute myself here. And proposal doc. There we go. All right, so let's go through this. So let's figure out what this is. So currently, the traffic redirection method for Z-tunnel is done in the host network space. By the way, let me know if the font is not big enough or something. I can make it bigger. Let's do it this way. All right, so host network namespace. So as CNI traffic logic also happens in the host network namespace, so this then leads to the incompatibilities between Istio Ambient Mesh and the various CNIs, because both of them try to manage the traffic in the same network namespace. So the goal of this proposal is to offer an alternative model where Z-tunnel traffic redirection happens from inside the pod's namespace, similar how it works with sidecars. So right now, if you go in and install Ambient, what happens is the Istio CNI plugin will set up the redirection on the node itself, right? What this is proposing is to do the redirection inside the pod's network namespace, right? So not on the host itself, right, or on the node. So we believe this will vastly simplify integrating Z-tunnel with different CNIs, solving a major problem for ambient beta. Because if you do the redirection inside the pod's namespace, you're not affecting anything, right? However, if you do it on the node, you might be affecting, well, not might, you will affect the CNIs, right? The other different CNIs. All right. So the background Current redirection relies on the Istio CNI node agent. So what the node agent does today is it's going to find the Z tunnel pod on the node and then set up the traffic redirection on the host network namespace from pods that are part of the ambient to the Z tunnel, right? So when you install it, the Istio CNI will set up the IP tables rules and the redirection it needs. So every time, so any traffic that's entering the node or exiting the node, and if it's part of the ambient mesh, will be redirected to the Z tunnel, right? And yeah, this is done with IP tables and IP sets. So if the Z tunnel ever restarts, the node agents needs to reconfigure the redirection and send traffic to the new Z tunnel. So what happens when the new pod starts? So the CNI binary is called by the container runtime interface to set up the networking. The binary contacts the Istio CNI node agent, and then the CNI Istio node agent will add the pod IP to an IP set. So it's going to be included in the redirection. So ztunnel or ambient mesh was using IP sets. So any pod that was part of the ambient mesh will be also part of the IP set, and then as part of the IP tables rules, what happened is that this IP set would be consulted, right, to say, hey, is this IP part of ambient mesh or no? If it is, then redirect it. If it's not, then don't. And then because all of this happens in the host network namespace context, host being the node itself, right? It's a bit fragile. If the CNI uses IP tables, IP routes, and IP rules, we need to make sure that our rules take effect before the CNI's rules, right? And then if the CNI uses eBPF for traffic routing, the network stack is going to be skipped, and then the whole ambient redirection logic is ignored anyway, right? So it doesn't get invoked. I'll get a comment here. Like the idea. The main difference here, so it can work with Tinky. Okay, so the main difference regarding performance is currently Z. Okay. All right. So the design of the new change. So let's go through this. So the key change that is being proposed is to deliver the pod's network namespace to the Z tunnel. So this way, Z tunnel can start its redirection sockets inside the pod's network namespace while still running outside of the pod. So this way, the traffic redirection will happen in a way that's very similar, functionally similar to the sidecars today, and it's going to be invisible to any CNI, right? So it's not going to affect anything. To the host namespace, network namespace, this will look like the pod has a sidecar with HBone enabled, and all traffic will be MTLS encrypted, and it's going to use the 15008 port. So the proposed changes to the flow, ztunnel and Istio CNI agent will now share a Unix socket for communication. Unix domain socket supports safely sending file descriptors between processes. Envoy has done this. So when a pod starts, the CNI binary will contact the Istio CNI agent as before, and then the CNI agent will do two things. So it's going to open the pod's network namespace. It will send its file descriptor to the Z tunnel over the Unix socket, and then it's going to set up IP tables rules to redirect traffic to the Z tunnel inside the pod's network namespace. The Z tunnel will accept the pod information and network namespace file descriptor from the CNI node agent, and is going to start the T-proxy socket inside the pod's net namespace. Combined with the redirection rules that were set up by the node agent, it will receive pod traffic. Similarly, how the sidecar works. Sorry, a window popped up. Something finally restarted. Okay. Just give me a second here. So what is the file descriptor all about? So let's see if there's more about this. There we go. So let me see. I'm going to be Googling here, but so let's do file descriptor. So they're saying how to listen to. Okay, so this is just a way to is there an equivalent of passing a file descriptor? You see, so the way that I understand this is like it's going to create like a pipe or something between the network namespace and the Z tunnel. Send its file descriptor over the sockets. I think there's going to be a pipe created right between the pod network's namespace and the Z tunnel, but I don't know the actual like an importance. What exactly is like? Why is it file descriptor here, and how does this work? If anyone does, let us know. So let's see. Files, file descriptor transfer. Oh, well, that's what it is, right? Looks like it. Cindy, there you go. Okay. So might not be the actual, but let me see. So so Unix domain sockets allow communication between processes on the same host system. Stream and data and socket types. Take that the user takes different path name. Okay. Do not involve person on the underlying device. Binding a name to Unix domain socket creates a socket file name path name. However, this file is different from the normal file. So you can create an echo server listening on Unix domain socket. So it's listening on this socket. So if you build and run a couple of, okay, so sockets are not normal files. Okay, maybe that's what it's meant, right? Because this might be the file descriptor. Let me just see. Socket pair, data transfer. Okay, so you can transfer data. File descriptors will file that. No, okay. So the difference between the two is subtle. So file descriptor is just a per process pointer to an underlying kernel data structure called file description. All right, why make it easy? Let's complicate things and name it in such a way that it's confusing. So the kernel maintains a table of all open file descriptions called the open file table. If two processes try to open the same file, the two processes might have their own separate file descriptors, which point to the same file description. Okay, so sending a file descriptor from one Unix domain socket to another one really just means sending a reference to the file description. So if process A were to send file descriptor 0 to process B, the file descriptor might very well be referenced by number 3, FD3 in the process, because it's this one, right? Table, however, so the sending, so even calls the file remain open. Okay, I think it just allows like the communication to happen, I guess, from the two between the two namespaces, right? All right, so there was a question in here that says, does the IP table rule redirect all traffic from the pod namespace to Z tunnel or only TCP DNS? Currently, it's TCP DNS. That's not implementation limitation. That's what Z tunnel currently supports. Yep. Any redirection you can do with a cycle, you can also do, yes, because it's IP tables, right? Okay, so where were we here, right? So in this model, with the small exception of a simple rule to flag kubelet health checks, there are no eBPF IP tables rules on the host net namespace, which is the key here, right? Because that way it's not gonna be interfering with any CNI, any rules, either IP tables or eBPF that a CNI might set up or use. And then no redirection happens in the hostnet namespace. Let me see if I know I had a diagram. So if we draw this out, it might be easier to think about it. Just see. Well, thanks everyone who's watching. I know it's Friday before holidays and all that, so maybe this one. Let's see. So many diagrams. Might be this one. Maybe we might reuse this. All right, so I'll zoom in. Let's go with, I think this one represents the previous state, right? Where you would make a request, you send a request from sleep to HTTP bin in this case, right? It would get captured by the IP tables rules. It would, this is a wrong IP here. There should be 101.2.4, right? So 101.2.4, because they are part of the ambient mesh, right? So we would send a request, and then on the node, the IP tables on the node would check whether who's sending the traffic, the pod that's sending the packets is part of an IP set, it's part of the ambient mesh. If it is, it's going to get marked, and then the tunnels, et cetera, to Z tunnel. And then here's the view across the nodes, but it is the same thing in the end, right? So you send a request, goes through the IP tables rules, gets redirected to the Z tunnel. Z tunnel goes back to different node, right? Gets redirected, PSTON to the Z tunnel, and then to the actual destination. But now what's going to happen now is, let me see if I can make a copy of this one. From what we've read so far, so there's no more group. So there's no more IP tables here, right? So there's no more IP tables. So I'll clean, I'll delete a lot of stuff here, but there's no more IP tables on the node itself. The Z tunnel pod is still going to be there. There's no IP sets, at least not on the node. However, what's going to happen is there will be a socket, right, created, a connection created. So all the rules, trying to zoom in here. So sleep. So we can say, so let's copy this one. Let's just change it a little bit. Let's make it red. Why not? So all the IP tables rules will now happen inside of the pod, right? That's why they're saying it's just like the sidecar model, but without an actual sidecar, right? So there's going to happen here inside the pod. So whenever you're going to send a request from, let's say, from sleep, right? You're trying to reach something. So what's going to happen is that the IP tables rules will redirect like any packets leaving the pod through this, I guess, socket here. I don't know how to mark it. Let's do blue, right? Oops. Let's do blue. Like this, right? So the IP table is going to capture it, direct it to this socket, and that's how the packets are going to make it to the Z tunnel pod, and then the Z tunnel pod will do whatever it needs to do to forward the traffic. Kareem's asking, are we actually bridging the pods as they are two independent network namespaces, or is this going through the, I think it's the network namespace. So this will happen, these changes will happen in the network namespace. And if I can get it up and running, we can actually probably, not actually probably, we can definitely take a look at the net namespaces inside the inside the pod and just see how it's set up. So this is how I understand that this is going to be. So let's go back. And okay, so we need to consider the restart. So what happens, like previously when zTunnel restarted, the Istio CNI had to redo all the changes again, right? Because the IP addresses of zTunnel pods changed, right? So you had to go and update the IP tables in order to route to those new IPs. So the CNI node agent, Lehman said, will also need to reconstruct the pod network namespace mapping and restarts. So if we add that, so there's going to be, let's add another, I'll just go with black here, select black. Like this maybe. So this will be the Istio CNI, right? So when this starts, this will actually go into, oops, let's turn it around, into the network namespace. I'm missing another rectangle here to just show that it's a network namespace, right? But this will go and set up the redirection in pods network namespace, right? So that's what the CNI will do. And so whenever it restarts, it'll have to like yeah, so whenever there's a restart, you would have to go and recreate those. So when the zTunnel restarts, it will receive the current node local pod snapshot from the CNI. Okay, so zTunnel will then receive, right, stuff from, whoops, from the CNI. I should probably change this, right? That way I don't have to. And this will be receive node local pod info, right? So this way. Okay. All right, so these above constraints make it clear that the CNI node agents will have an in-memory cache of the node local pods in their network namespaces. Okay, so this will have the cache. I don't know how to show the cache. Let's do this like this, and maybe green. Why not? And this will be cache. And what's going to be here, there's going to be, I think, some sort of mapping for pod and network namespace, right? Or something like that. That's what they said. So the node, the CNI, will have maintained this and consult this cache, right? So in-memory cache of node local pods and their network namespaces. This can also help dynamically enabling and disabling yes, without requiring a restart of pods. Yeah, so if this is done, like if this exists, it would mean that the pod is part of the ambient mesh. So you could, by removing this, remove the pods without even restarting them. Right? Trade-offs. So zTunnel will now need an additional capability, so it can open its sockets in other network namespaces. So set NS system call. Yeah, so this sockets. So zTunnel will go and open the socket here, right? It's going to open the socket in. It's not going to create it, right? This is going to be set up here, and then this one has the capability to go and open a socket. Additional access, the zTunnel will now have additional access to the pod network namespace. This doesn't degrade, we believe this doesn't degrade the threat model significantly, especially when compared to sidecars. So today, zTunnel already impersonates the pods, right? So if the zTunnel is compromised, too bad, right? I mean, you're in a bad state anyway, right? having access to the network namespace doesn't change that if you can already like impersonate anyone. Having the network namespace will allow you to access ports that are bound to localhost. This is similar in impact to compromised sidecar, which seems to be an acceptable risk today. Okay. So more listening sockets will be open. A constant number, currently 4, as many as the number of default listeners ztunnel. Okay, so anything that ztunnel has, the listeners. So let's see. I think I have that somewhere, right? Yeah. So these are the listeners on the ztunnel right now. So these will be the same. So this, let's see if I can ungroup, and if we can copy this. I don't know if it's going to make that diagram easier to understand or more complex. But hey, I'm trying to understand this as well. So let's do this here. Let's group it. So this one, thought I grouped it. And then we have these ports. I'll just remove the numbers. So it's, yeah, so these will be now, let's see, how can we do this? Let's group and move. I didn't think this will turn into me drawing diagrams, but hey, here we are. So we can move this here, right? We know that it's going to go through IP tables. And then over here, we'll basically have like these 4, how did they say? Yeah, so listening sockets. So there's going to be 4 listening sockets created in the network namespace of the pod. Yeah, okay, so now this might be more understandable now. Yeah, so the IP tables, you send a request, the IP tables will, the packets will flow through the IP tables rules, and then they will end up on one of these, right? One of these sockets, right? And then this, because it's connected to the ztunnel pod, the ztunnel pod will receive those packets and will be able to do whatever it needs to do, right? I think that's what, that's why they're saying it's looking similar to the sidecars, right? Because in the sidecars you had a pod, right, and then you had your sidecar container here. Make it red, and then you had your app container here. And this was your app. I don't know why this is green. Let's make it black. And then this one was the sidecar, right? So all this, like these, the ports, I guess, right? There were ports here that the sidecar was listening on, right? And then the IP tables that happen, the IP tables rules were inside the pod as well, right? So the traffic got redirected or captured, I guess, and then redirected to one of the, one of the listeners here, right? And then the traffic went out, right? So the same, functionally the same thing, but it's not a separate container. It's in the actual like pod network namespace, right? Wherever these IP tables rules live. All right, let's go back. Okay, so yeah, 4 sockets, as many listeners that ztunnel currently supports, and their associated ztunnel listener will open per pod, yes, instead of per node. Yeah, so if you have you'll have multiple of these, right? Let's make this a little bit bigger. I don't know if I really want to copy paste this, but I'll copy paste it. Just make it maybe smaller, right? And we'll call this app. Go smaller, smaller, and there's going to be the same, right? Same thing here. Like this, right? So for every pod, there's going to be 4 of them, right? Per pod, right? Instead of per node. The threading model doesn't change, so we do not expect to see a big difference in system resource usage, right? So no actual like performance impact. Yes. Kareem, why would the sockets be on the app side, and wouldn't this mean that your container ports will have to be modified? I don't think so. I don't think you have to modify the container ports. There might be something that would, like, I would assume maybe you won't be able to use port 15008, right? Or any other ports that are part of these sockets, right? But I don't think it should impact anything. But it's definitely a good question. We'll see. Maybe they talk about it in the document later on. Okay, so network policy. So similar to Sidecar with HBone, all traffic leaving the pod will be on the HBone port. That's 15008. So network policies that rely on rules referencing explicit non-HBone ports might break once traffic is HBone encapsulated over port 115. Our understanding that the number of network policies that explicitly use a port. Okay, so there is going to be something. Let's see if attached. Okay, so it seems that all network policies attached to the pod IP will be bypassed, not just policies for port. Am I missing? Why would they get bypassed? The packets still make it to the pod network namespace before, so network policies can still work. So zTunnel will work as a remote proxy sidecar. All traffic will be intercepted to zTunnel and redirected back to the pod after remote proxy sidecar is processed. Am I right? Yes, though I wouldn't use the term redirected here. After the remote zTunnel processes the traffic, it will proxy it to the destination pod from the pods. Okay, so it's going to go from there. It's not going to be, so if you go back, so the traffic will go through the IP tables, but it's not going to be then sent from the zTunnel pod, right? It's going to be sent from the pod's network namespace out, right? Okay. Could there be socket exhaustion because of this? I thought I saw this. I don't think there should be, right? Because it's going to be 4 per pod network namespace, right? I don't think unless there's a limit per network namespace. I don't think there is, but we'll see. For some reason, I thought I saw this somewhere, either a comment or I don't think there could be, but hey, you never know. Okay, so because the network redirection rules happen within the pod, we lose the ability to guarantee traffic goes through zTunnel at the host network namespace level. So this could prevent, for example, Istio egress policies from taking effect. It would not, however, prevent CNI enforced network policy egress policies from functioning as they do today. Okay. It should be noted that even today, we cannot guarantee traffic goes through zTunnel at the host network namespace. We rely on a node agent to configure the host network namespaces, and we rely on other node agents to not break that configuration by mutating pre-appending rules. An assumption that in practice frequently is a breakage, which we do not and cannot detect. So short of recycling our node agent. So now we have already fixed multiple bugs where workload traffic was not correctly captured, and the only way to detect this was like grepping. Okay. All right, so looks like there's an issue already open. Oh, I guess it was already closed and fixed. Lose CNI, yeah. For future iterations, we can add future mitigations, such as using eBPF grep bind 4 program to only allow ztunnel to bind to ztunnel. Okay. All right, so from the pod, does that mean it will require at least one thread per pod? Okay, so no thread, no, the threading model does not change. Net namespace is attached to the socket. Policies will work. The rest of the Kubernetes, to the rest of the Kubernetes, it looks like the pod is magically docking HBone on point. For egress, we'll harpen the traffic from ztunnel. That's a question. Will we hairpin the traffic from ztunnel and traffic goes out via the original pod interface like sidecar mode does? Not sure, but yeah. Outbound, okay. In the host network name, it will look like the pod has a sidecar that's talking HBone. Okay. In addition, the new mode can be made optional, so people who have strict requirements can use a different redirection model. And as always, people are free to write their own CNIs or write agents that integrate differently or more directly. Alternatives considered. Adding different redirection methods for different CNIs. Oh, basically, creating an inventory of all CNIs and then implementing those specifically for each CNI, right? Which would probably be a nightmare to maintain. Very long. All right. Oh, okay, there you go. Why did I draw that diagram? Now we can go and compare if I was right or if I was wrong. But okay. All right. So node, and then pod. Okay, pod 1, pod 2. So everything entering or exiting a pod hairpins through the local Z tunnel. Okay, so this is inbound, so outbound, right? So we're sending a request. So 5151, whatever, we're sending a request to 5151. It gets captured by the IP tables in the pod network namespace. It gets redirected to proxy for encapsulation on the specific outbound socket, right? That's the 15001 port, one of those ports. And then from here, it gets sent through, leaves the pod as HBone on 15008, and then targeting 5151 because that was the target. And then the inbound traffic comes in. Target is port 80. It's going to go through HBone. It's going to, IP tables will capture it, proxy it for on 15.8, and then back to the actual application on port 80. So looks just like old sidecar to the CNIs and to pods without actually adding a sidecar. Sidecar with long straws. Yeah, these are the straws, I guess. But yeah, plain text traffic, port 80. Yeah, this same thing, right? It just goes to the plain text 15008 and then 15001, right? And this one is 6 and 008, I guess. Everything entering hairpins again through the local Z tunnel. All redirection happens within the pod. Nothing happens on the host, just like the old sidecar. Pod configuration flow. All right, so this one is draw a little bit of this one as well, I guess. This part here. So let's see. So we have CNI pod configuration flow, a node. So CNI pod gets deployed. It's going to jump into the workload namespace and write the IP tables rules. Yeah. And then it's going to notify ztunnel to create the workload proxy. And then ztunnel is going to create those sockets, listening sockets inside the workload net namespace. All right. So CNI creates the IP tables rules and then tells ztunnel to go and set up the listening sockets. That's why ztunnel needs those the admin capabilities. Yeah, and that's how it's set up. So watches, so Istio CNI, the agent is going to watch for any new pods, and then set up the in-pod IP tables, and then ztunnel owns the sockets and subscribes to the CNI agent events. Okay, so whenever a pod gets added or removed, I guess, ztunnel pod needs to know that so it can go inside the workloads network namespace and either delete or create the sockets, right? This redirection is tells them beta blockers. Yep. Yep. All right, that was it. That was pretty short. I think fairly, I would say high level, fairly straightforward to understand, I guess, if you've done like if you have a little bit of understanding of how Istio works and Ambient works. So let's see if there's, I think there's a PR. We can look at the code a little bit maybe. So there was one from Paul. So let's see, ztunnel. Okay, so this is the actual code. So Z in pod redirection mode. Context, we just looked at it. So this adds the new optional redirection mode. And I was looking at some code, and it's I'll show it how it looks like. And then Ben's gonna do. I saw Ben's PR, I guess. Okay, so in pod is the new redirection mode that's set up. College progress. Yeah, okay. Yeah. Oh, it's Rust. I don't know if I can read Rust. Let's see. Wasn't this one? Oh, we can click on the code. Let's see. See how much I can read Rust. Probably not much, but let's see. This might be harder to read, but I'll zoom in. I just want to get my bearings to see what's where and what's what. It's good. Oh, okay. This is for tests. Okay, so this is for tests. Oh, I guess we have the IP tables rules here. I don't know if I want to go through the IP tables rules. At some point for me is just enough to understand that and it intercepts it and then it sends it there, and then on the way back it does the same thing and sends it somewhere else. But yeah. So this is just for testing. Oh, why does it mess up if I zoom in? There you go. Okay. Does anyone know how to read Rust? I tried doing some Rust, but I never got anywhere because I didn't try hard enough, I guess. But let's see. See if there's anything that we can recognize. Oh, we can recognize this, right? In pod mode enabled. Server. DNS. There's a lot of changes here. Okay, so in pod, I guess this is the one, right? Let's see. Init and new. Verify that we can make the permission. Okay, so this will actually go and then connect to proxy. Oh, man, this is so hard to read for me. Rust. All right, tests. We know that those are tests. I'm not going to go through tests. Was that it? Up here. So init and new. It's going to verify that we have permissions. It's going to set up metrics. It's going to add a handler for, I'm assuming, metrics. It's going to create new in-pod configuration by passing in configuration that gets passed. I guess we should see where this gets called. And then state manager. I'm going to create a new state manager with the config. What is proxy gen? Proxy factory. Okay, proxy factory knows how to create those. And then we're going to create a new workload proxy manager, I guess. Okay, this is the in-pod admin. Manager, admin handler, proxy up, proxy pending. Oh, okay, so these are just, I'm assuming these are events. I don't know. 2 bytes, workload manager, admin handler, response, test, config. Okay. Yeah, this is way too. That's too low level for me, especially reading language that I'm not fluent in, I guess. Net namespace. Okay, so it's opening the network namespace. Logging, debugging, run. Yeah. Packet. Anyway, we'll trust that this is, we're not going to review this code. Not me for sure. So let's go back. I want to see the CNI portion because I know that one's Go and that one is easier for me to read. So let's see. Let's see if I can find. No. Let's see what the. 3 hours. So Yuval is working on this very, very actively. Let me see if I want to find Ben's. Oh, there you go. Cilium CNI for Ambient. Okay. Oh, this is just an issue. Where's the actual work? Maybe this one. This one was closed. This one was closed as well. PRs. See. Oh. All right, so these are instructions that we can go through. I tried. Didn't work for me, but we can try again. Maybe it'll magically work. Let me see if I can find Ben's PR. It's to be like PR. Oh, I know why I can't find it, because it's in a different repo, I think. I think the Istio, the CNI might be in a different, no. Let's see. If anyone finds it, let me know. Paste the. Oh, I didn't type. Oh, Oh, maybe it's no, but this is just an issue. So Slack context, I think this one just goes to ambient dev on the STO and the STO Slack. So Costin is working on this. Let's see. Oh, but this was like April. Not STO CNI. This is on Z tunnel. Yeah. Oh, there it is. It was here all along. There you go. Found it. So this is the CNI changes. Okay. A lot of a lot of files were deleted, which is, I guess, good for maintaining code, right? Thanks, Kareem. Have a good weekend. Hello, Sarah. So, okay. So this is all the details of the IP tables, how they get set inside the pods network namespace, right? Yeah. I'll paste this in the chat if anyone wants to take a look. What is time? Coming up on an hour. Let's see if we can, if I can make it work. Lynn posted those, the instructions there. So I want to try and get that to work this here. So let me see, since everything restarted. See if I can log in and I'll share my screen. Oh, perfect. Okay, so let me stop sharing and I'll reshare the whole thing again. Entire screen. Yeah, there you go. All right. So I do have I've set up a Linux box because apparently it doesn't work on ARM64, which is exactly what I have. So let's see. So I do have alias. I think I deployed something. Oh, I didn't. Perfect. So let's do create a cluster. So I'm going to create a cluster, and then I'll try to deploy install STO using this image in pod image. And I have these files. Let me see. Open folder demo. I think I opened it here. What? Okay. Oh, did I lose the? Oh, I lost my connection. Anyway. All right, so I do have a cluster running, and then I did. So if I go in pod, if I go into the folder here, these are the instructions. These are the files that Lynn mentions in her post there in the comments. So the CNI, it's the Istio operator. So it's setting this redirection mode to in pod. And I think these other settings are just default settings, right? This is the only difference here. In pod, and then enabling the CNI. And then the manifests, I don't know if there's any specific changes here. And the manifests, I don't think there are. Well, there might be, but I don't think there are. So let's just see if I can get this to install and see if we can get it to work. Let's just do this. What is the... Anyone know what the default Tmux hyperkey is? Default Tmux hyperkey. Sorry, I split my... Oh, Control B. Okay. It's Control B this. Oh, Control B this. No, that's what I was doing. Anyway, I'll open a different terminal. There you go. And we'll make it a little bit bigger. Okay, so we have the two. I have the cluster, or maybe I don't. I do. So the cluster is running. So what we'll do is I'll install Istio from the manifest folder using this image, using the stack with the profile ambient, using this operator, and then setting the log level to debug, everything to debug. So I am in pod. So if I paste this here, oh, but I have installed Istio. So let's do, this is what I get for not, let's if we do Istio local. All right, this should make it work, right? Demo impod istio-ctl. No, it's not. I thought it was part of the. Anyway, let's do this. Oh, come on! Since it's only the one command, so 1, 2, istio 121 120.1/bin. This should work now. There we go. All right, so it is installing. And I think last time I tried, or before, I guess, it just didn't start. Let's do full screen here. We don't need those instructions anymore, I guess, right? Yeah, because then it's just labeling the namespace and deploying the sample app. So let's see. If it works, it works. If it doesn't, call it a day. And I'm thinking next year I'll probably bring either, oh, it installed. Perfect. Look at that. I'll either ask Yuval or Ben to come on and do a much better explanation of all this than I did. All right, so we have the CNI. Let's look at some of the logs there, and the Z tunnel is there as well. So Istio system. I guess, oh, it's debug. That's what we get. That's why we get all these things here. So what we could do is I'll just label the namespace, the default namespace with data plane mode ambient, and then we'll deploy the book info applications. Let's do that. Let's do this, and I'll just make sure that this comes up. All right, looks like it's up and running, I think. Yep, it's up and running. And what was the last thing? Oh, you can see the, oh, perfect. We can take a look at the sockets with this command. Let me just do this. So how's the font size? Hopefully people see this. So kubectl debug, kubectl get pod, app product page name, IT. Oh, okay. So this is, so let's close this one. What is a debug? Oh, nice. Okay. Oh, okay. So it's just getting the pod name and then using this net tools image and then running the command there. And this is for the product page. So let's look at this. And I think we'll see the sockets there, right? There you go. Yeah, perfect. So this is from inside of the product page. And yeah, so you can see that it's listening on these. So this is the actual application, right? The app. And these are the, I guess this is DNS, right? And the four Z-tunnel sockets. That's perfect, right? So you can basically install this with any CNI. Kind of want to try it, but well, let's see if we can get it to work, right? So let's see if we can do kind. We'll just delete clusters, kind get clusters. Let's delete everything. And then I'll go, do I have it here? I'll say kind create cluster config kind, so with no CNI, and then I'll try to install Cilium and see if this works. So this is off the path, going off the path a little bit. See what happens. Almost there. All right, perfect. So we have a cluster without a CNI. So we should, oops, all, yep, pending, makes sense. And then we'll do, I have Cilium here, I think. Yeah, so Cilium install, go. Oh, Cilium status, right? This might take a bit as well. Oh, it looks like my face is covering up the, oh, this is better. Okay, so all good. So we did all this. What was the, oh, installing Istio. So we go impod, and I'll go back to this command here. Go. Let's open another one so we can watch it. So same as before. It's not going to work. So I have to, I don't have istio-ctl in my path. So 1.2 istio 121 bin istio-ctl. Now it should work. Okay, so it's processing. Now let's see if this comes up. Oh. I'm just going to install my dot files here. Oh, I'm wondering if, so the one that I have, well, let's see what happens here. Istio system. So the Z tunnels, 2 of them came up. So the CNI node have, okay, so the Z tunnels are up and running. So the CNI nodes, and I have 3 of them because I installed 3 nodes. I wonder if it's something, because this is taking longer, right? Like the previous one was much faster. So I wonder if it's the previous demo that I did only had one node, and this one has three. So I wonder if there's like something that's still being worked on to make it work like across multiple nodes. I don't know. No. So all the data changes, checking to see. Yeah, I don't know if these aren't errors, right? These are just info messages. But it's taking way too long. I think it's, yeah, so let's do this. Let's try with last thing. Let's try with delete clusters, kind get clusters, and we'll try with a single node because, so let's do this. All right, let's do a single node and see if that's the reason maybe. So this is deleted, and then I'll say create cluster config. Oh, wrong folder. It's kind create cluster dash dash config kind. Do this. There should be faster now as well. That's why it was taking so long, because there was 3 nodes. Do that. I'll start this one. Actually, what if, oh, you know what? I wonder if it's, so let me use the Helm installation. There you go. So Helm, Cilium, namespace. Yep. So let's do this. What? Repo. Oh, Helm update. No. What is the... oh, I have to add the repo. There we go. So adding the repo. No. And installing Cilium with Helm. Cilium status. Get 1 error. That should go away. Hopefully. Yeah. Starting up. Almost there. One more. Why isn't it ready? One is ready. The second one isn't. What? Why is this one pending? Oh, I'm not going to get logs if it's pending, right? Of course not. Yeah, so one is up. No. Scaled up. Didn't say anything. Interesting. I don't know why this is failing. Well, let's see. Let's try our luck even with if the operator is failing. So let's do let's deploy the book info. So we'll see if book info comes up. I think it should be. Yeah, I think it should. We should be fine. So this is coming up, and then we have to go and install. I don't know why is this failing. Yeah, so one is ready, one isn't. Is it? Maybe I don't have enough memory or something. Could be. I don't know. Let's see, because if I don't have enough memory, then it doesn't make sense to try and install Istio either. It's not going to work. Yeah, there's nothing else. All right. Okay, so then these wouldn't come up either, so we're fine. Okay, so let's install Istio now, and let's see if it comes up. If it doesn't, we'll end it there. If it does, we'll end it there as well. Let's see. So STOD is up. Z-tunnel should be next. So Z-tunnel is up. We have the debug logs, right? And now we need the CNI node to come up. Yeah, it looks like it's the same as before, right? There's no, it's not saying anything. Oh, there you go. So install missing or invalid configuration detected. Oh no, oh, there you go. Yay, it's up. So let's do this, right? Perfect. So I have Cilium running with ambient mesh, and it works. Right? Let's actually try and label the namespace. I don't think I did that before, right? So let's make it part of the ambient mesh. Let's see if there was anything here that happened. Probably did. Yeah, I guess debug. We're probably not going to go through that. Let's also see some logs from the. Oh, but look at that! It went down. Let's look at the logs here. Let's see. Oh, there's going to be too many of them. Yeah, there you go. So it did. So we made it part of the ambient mesh. So it did prefetch the certificates, right, for reviews. And then I'm assuming it's going to be other workloads there as well, right? Somewhere. But yeah, so it might be working. So let's take a look. What was that? What was that command? This one. Let's see if the namespaces or the sockets are set up. Or maybe not. Maybe there aren't. Oh, yeah, there are. Perfect. Look at this. So we have ambient mesh running with Cilium CNI, and it works. This is great. That's awesome. So if anyone is using CNI, previously you weren't able to do this, well, guess what? We're not going to say now you can, but the changes are out. The PR is out. So don't know where it's going to get merged, but what it matters is it's out. It's being actively worked on. So yeah, it's exciting. Well, awesome. Took a little bit more than an hour. Hopefully people enjoyed it. And yeah, enjoy your weekends. Enjoy your happy holidays, I guess. And I'll see you in January. Bye, everyone.